So on question 1, we have the limit of x to 4 of the quadratic equation 2x squared minus 3x plus 4. So what we're going to do is we're going to directly substitute x with 4, because when we do so, we do not have an undefined function. So when we substitute, we're going to have, remember, we're going to have wherever there is x, we put a 4, and that's going to be 2 open brackets 4 squared minus 3 open brackets 4 plus 4. And then if we multiply accordingly, we're going to end up with a 32 minus 12 plus 4. And this, if we subtract and add respectively, we end up with a 24. And that is our answer for A. So for B, we have x to the limit of x to -2, and our function is x cubed plus 2 to the power 2x to the power 2 plus 4. 5, and the denominator of 5 minus 3x. So here we are going to substitute directly, because if we look at this fraction, whenever you're dealing with a fraction, I feel like this is important. Whenever you're dealing with a fraction and you look at the denominator only, if you were to replace whatever is in the denominator with whatever our limit is requiring of us to find, and you do not get a 0, which means that you can replace everything out and find the answer for the entire equation. So if we replace the numerator with x, we get -x cubed plus 2 open brackets -2 close brackets squared plus 4. And then in the denominator, we get 5 minus 3 open brackets -2. So when we multiply accordingly and respectively, we get -8 plus 8 minus 4 in the numerator and 5 plus 6 in the denominator. And then when we do the respective addition and subtraction, we get 4 over 11. And 4 over 11 is the answer to B. So for C, we have the limit of u to -2. So in this one, we're going to do the same thing we did for the other two. We're going to replace u with -2 and find the answer after we solve. So when we replace, we get -2 to the power 4 plus 3 times -2 plus 6, all that under the square root. So this is what we get. We get square root of 6 minus 6 plus 6. The minus 6 and plus 6 will cancel out to give you square root of 16. So square root of 16 is 4, and that is our answer. We are going to have to simplify first. Why do we need to simplify first instead of just like replacing the x with 2 everywhere? Why? Because if we were to replace x with 2, according to what we've been given, this 2, we put it here, we're going to end up with 2 minus 2, right? And 2 minus 2 is 0. And whenever you have a 0 in the denominator, that will automatically give you an undefined equation. It will just be undefined, which means that there are no real answers. And that is, we normally never have such situations. So what we're going to do is we're going to simplify. So a trick I learned about having a situation where you have this in the denominator is you can end up dividing what's in the denominator with this in one of 2 ways. You can end up doing that, or you can just factorize this and then cancel out the like terms. So we're going to use the shortest method possible. So we're going to first factorize this separately. So x squared plus x minus 6. So the sum of this is the coefficient of the middle term, which is 1. And then the product of all this is negative. Yes, p. The product is -6. So what two numbers multiply to give you a -6, but add to give you a +1? That will give you a 3 and a -2. So therefore, your factorized version of this quadratic equation is x plus 3 x minus 2. So what we're going to do, we're going to take it back into the original equation. So limit of x to 2. Please, this is very important. Always make sure that when you're working out, you always put the limit to the side. Always. And the only time you stop putting this at the side is when you've replaced the x with whatever limit we've been given. So in the numerator, we're going to put this factorized version of that quadratic equation, and we're going to put back the denominator just as it was. So when we look at it the way it is, we have x minus 2 in the numerator and x minus 2 in the numerator. They will cancel each other out, leaving you with the limit of x plus 3. Now at this point, this is the simplified version of it all. So we're going to replace it. We're going to now replace x with 2. So 2 plus 3 will give you a 5. And that is the answer to this question. Okay. So for E, we have the limit of x to 5 of x minus 5, x squared minus 25. So we cannot replace directly, because if we do, we're going to have 5 squared minus 25. That will give us 0. And when you have a 0 in the denominator, everything is undefined. So what we're going to do is we are going to simplify this as much as possible. So if we look at the denominator, x squared minus 25, so they are both perfect squares. So the square root, the things that what will multiply to itself to give you x squared is x, and what will multiply to give you 25 is 5. So we're going to end up with, due to the fact that there's a minus here, this will give you a difference of 2 squares. And it's going to turn out as x minus 5 over x minus 5, all of that in brackets, times open brackets x plus 5. Difference of 2 squares. So we'll have different signs, but it will be the same values. So we're going to end up with this x minus 5 over x minus 5 brackets multiplied here by x plus 5. And then if you multiply these outwards, if you multiply x by x by plus 5, x here and there, it will still take you back to this. So this is the factorized version of x squared minus 25. So if we look at this, we see we have an x minus 5 in the denominator and an x minus 5 in the numerator. So these two will cancel each other out. So you have when you cancel, you have a 1 at the top, and then you'll be left with x plus 5 in the denominator. Remember to put the limit at the side. So once you do that, now at this point is when you are free to substitute x with whatever limit you've been given. So when you substitute, you end up with 1 over x over 5, actually 5 plus 5, which is 1 over 10. And this is the answer to E. So for F, what would be wise, if you look at it, you cannot substitute directly because the 7 will give you a 0. But after trying to work this out, you will find that this entire, it's like there was an error in answering in this, the way this question was set up, because it apparently does not have a value once you try to work it out. So I don't know if there was an error, but this question is particularly undefined. It does not have an answer, because no matter which way you do it, you will always end up with an undefined value. So for G, we have the limit of x to -4, and this is our function. So we cannot replace directly, because if we do, let's say we do, we're going to end up with, let's just look at the denominator. We see if it will give us a 0. So if we replace, so we're going to have a -4 squared plus a 3 open brackets -4 minus a 4. So this squared will give you a positive 16. And then this times this will give you a -12. And then minus 4. And if you were to do the math, if you do the mathematics, so this minus that will give you a 4. 4 minus 4 will give you a 0. So we are forced to first simplify this. So how are we going to simplify this? First, we're going to individually, we're going to factorize this, and we're going to factor we're just basically going to break it down into its most simple components. So when we do that, we're going to start with the numerator first. So this is our numerator, x squared plus 5x plus 4. So the sum, so it's always the sum product, always in this order. So the sum is positive 5, and then the product is a 4. So the two numbers that when you multiply to give you 4 and add to give you a 5 are positive. So so if we find the sum product and factor of this, so the sum is 5, the product is 4. So the two numbers that will give you this, if you multiply and add, is 4 and 1. So the factorized version of this quadratic equation is x plus 4 brackets x plus 1 as our numerator. Now the denominator. So with the denominator, we're going to do the same thing. The sum is 3, the product is -4. And what are the factors? 4 and -1. And then, so when we do as y's, we get x plus 4, x minus 4. So we're going to replace them back into the equation as they are as denominator and numerator respectively. So limit x to the -4, sorry, over this x plus 4 brackets x plus 1. And then the bottom is x plus 1, x minus 1. So we have an x plus 4 in the denominator and the numerator. So they'll cancel out to give you 1. And then we end up with just the limit of x to the -4 over x plus 1 over x minus 1. Which will, and when we replace x with 4, this is what we get. So when we replace, the limit that we've been adding consistently goes away. We no longer need to add it anymore. So we end up with a -3 over 5, and because the negatives, oh my god, sorry, because the negatives will cancel out, it will be 3 over 5. And that is the answer to the question. So for h, with the limit of x to 2 of this x squared plus x minus 6 over x minus 2, all this to the power 6. So we cannot replace it directly, because if we replace this 2 here where there's x, you end up with a 0. So we will first of all, as usual, we have to simplify this entire thing. So when we simplify, we're first going to break this down into its simpler versions. So when we break this down, we end up with a sum of 1 and a product of -6. And what do you get as the factors? 3 and 2. And then we replace as y is going to be x positive, so plus 3, negative, so x minus 1. And this is what we get in the numerator. And then we're going to take this back into the original question, but yeah, we're going to take it back. So we're going to have the limit of x plus 2, no, x to the 2, then replace this over that. So the thing is, we have an x plus 2 plus 3, x plus 3, and x minus 2. And then we have an x minus 2 in the denominator. So the denominator will cancel out with what's it's equal to in the numerator. So these two will go, leaving you with an x plus 3 to the power 6. So x plus 3, now we replace. When we replace, the limit here goes away. It's no longer there anymore. So when we replace, we end up with 2 plus 3, all that to the power of 6. So 5 to the power of 6. If you can, I would have left it in this form. But for the sake of the video, this is what we get when we multiply 5 6 times. We get 15,625, and that is the answer. Though I would advise this form to leave it this way because we don't use calculators, and multiplying this throughout will be a bit tedious. So I would have left it in this form instead of this one, but if you can leave it in this form, it's fine. But personally, I would have chosen to leave it this way. So this is the answer for H.
Yeah.
So for I, which is the limit of H to 0 of square root of 1 plus H minus 1 over H. So we can't replace directly because this will be a 0. So we need to simplify. We need to break this down into a simpler version of this. So what we're going to do is we're going to multiply the top and bottom by the conjugate of the numerator. So the conjugate is just itself, this whole thing, just the way it is, just as it is. The only difference is going to be this. That's the only difference. So a conjugate of anything, let's say you have x minus a. So the conjugate of x minus a is going to be x plus a. And then the conjugate, let's say, of x, 2x minus 3. The only thing that's going to change is that. So it's going to be 2x plus 3 as the conjugate of this first one. So that's basically what a conjugate is. That's all. So what we're going to do is we're going to multiply the top and the bottom by the conjugate of the numerator. So when we do that, we multiply them out, right? We're going to say, so this h, square root of 1 plus h, there, we distribute it out accordingly. And we also distribute this out. But the thing is, we're not going to split this as it is. This one at the bottom will remain as it is. So when we split it out, it stays as it is, right? But the thing is, when you multiply something with a square root by its conjugate, everything will remain the same on the square root part, only that the square root will disappear because you've multiplied it by itself. So it's going to be 1 plus h minus 1 over h times the conjugate, which is all of this. So if we look at the 1 and the minus 1, these two they'll cancel each other out, leaving you with h alone on top. So the thing is that we have an h at the bottom and we have an h at the top. They will also cancel each other out. Remember to always be putting the limits. This is extremely important. Always put the limits at the side. So afterwards, we have the h's and they will cancel each other out. They'll go away, leaving you with a 1 because h divided by h is a 1. So it will be, there'll be a 1 here and then there'll be a 1 here, but we don't really write the 1 at the bottom. But the 1 on top is quite important. We leave it as a 1. So we are left with a 1 over the square root of 1 plus h plus 1. So at this point, we cannot break it down any further or make it any more simple. So it is at this point when we now get to have the privileges of replacing h with a 0. So when we replace h with a 0, we end up with this. Sorry, this is supposed to be a 1. So let me just rewrite it. It's going to be 1 over the square root of 1 plus the h, which is a 0 now, plus 1. Yeah, this is what it's going to be. So if we look at it the way it is, so the square root of 1 plus 0, 1 plus 0 is square root of 1 plus 1. And the square root of 1 is 1, which is here. The other possible value for the square root of 1 is -1. But if you put a -1, it will be undefined. So we can't do that. So we put +1. So +1 plus 1 will give you 1 over 2. So this 1 over 2 is our answer. And we are done for this question. So for j, which has a limit of x to 2, x to the 4th minus 16 over x minus 2. So we can't substitute immediately because it will give us an undefined equation here. If we put a 2 here, it will give us a 0 in the denominator, and that will give us an undefined answer. So we're going to break this down into its simplest versions. So what we're going to do is this one. What we're going to do is this. We're going to take this to this version. So this is because we have this, the x to the 4th minus 16. So this whole thing is actually a difference of, it's a product of a difference of two squares. So it's going to give you, if we break this down, what's the square root of this? This is x to the squared, which is this one. And what's the square root of 16? It's 4, which is here. So we're just going to put it in this version. So it's x squared plus 4, all that in brackets, x squared minus 4. Because this is and if you multiply this out, it will take you back to this. And then the numerator stays as it is. So if we look at this, right, we still cannot do anything to simplify. So we need to break this down a little bit more. So when we look at this right here, this is also a product of a difference of two squares. So we can break this down. Yeah. So the square root of x squared is x, and the square root of 4 is 2. So we're going to break this down further, more than it is, to give you this. To give you x squared plus 4, which is, it stays constant because we haven't done anything to it. And then it becomes x plus 2 bracket x minus 2 over x minus 2. Remember, the limit, always put it at the side, provided you haven't replaced x with whatever limit you've been given. So when we look at this, we see there's an x minus 2 at the top, and then there's an x minus 2 at the bottom. These two will cancel out to give you a 1 here and a 1 here. So when they cancel out, you are left with this. So x squared plus 4, open brackets, x plus 2 over 1. But eventually this 1 will become pretty insignificant. So at this point, let's just ignore the 1 for now. So at this point here, we're going to replace, we have now the privileges of replacement. We can replace wherever there is x, we put a 2. So it becomes, we put a 2 where there's an x. X, here, comes down here to a 2. So 2 squared from the to x squared plus 4, 2 plus 2. So 2 squared is 4 plus 4 is 8. 2 plus 2 is 4. So it's going to be 4 plus 4 times 4. It's going to be 8 times, because in between here, it's automatically, there's a multiplication symbol. So 8 times 4 is 32. So this 32 is our answer for this particular question. So this question, the limit of x to negative 4, or 1 over 4 plus 1 over x over 4 over x. So this is a bit of a complex looking fraction, but it's really not that, it's not as complicated as it looks. So what we need to do first of all is get rid of this fraction part. We have to find a way to get rid of it. And what's the best way to get rid of it? We're going to multiply everything here by the product of these denominators. But then whatever you do at the top, you must do at the bottom. So we're going to end up with this. So the product of the denominators is 4x. So if you say 4x times 4, you're going to end up with, so let's say 1 over 4 times 4x over 1 over 4 times 4x. There's automatically a 1. So you multiply it directly. So 1 times 4x over 4. So these two will cancel, which will leave you with an x. Same thing if you say 4x times 1 over x. They'll multiply, right? But then the x will cancel out the x on top, which will leave you with 4. So what you'll get at the end of it all will be if x plus 4. This is an x plus 4 in the numerator, and then in the denominator you have f4x open brackets 4 plus x. So this is what we get. So the thing is, this value and this value are the same. It's not when you have a plus b and b plus a, they're the same thing. These are the same thing. These are the same thing. They are one and the same. So because of the same thing, they'll cancel each other out, leaving you with a 1 at the top and a 4 in the denominator. So at this point, we now have the rights to replace. So wherever there's an x, we put a -4, and it gives us that 1 over 4 times -4, which will give you a 1 over -16. Yes. And that is our answer for K.